Hello, my name is Eliza Bosmans, and this is my lab 2 for charge tapes, which was just the extension of lab 1, where this is just a computational model. The purpose of this lab was to produce a computational model with 2 charged tapes, both exerting an electric force on each other to estimate the amount of charge on each tape necessary to make the second tape float above the other, and therefore having not greater but equal force exerted to gravity. And then the main results are given right here. These two were the output of the computational model. And then these were results of other comparisons to lab 1, where this was a percentage calculated based on the old Q. And this is the Q value that is needed to actually make the tape float, which you can see is very different from the Q value here. And the key ideas and equations. Coulomb's law describes the force of a particle on another particle. The electric field describes the electric field of a charged particle. Gravitational force describes force of gravity acting on a particle, and then electric force here is just the charge times the electric field, and superposition is all of the individual electric fields summed together to make the net electric fields. And also these electric fields are vector values, and the force is vector values as well, and are. And then the experimental design, the systems were the tape B and tape A, or the tape on top and the tape on bottom. Surroundings is everything else. Air resistance is negligible. Tape is segmented into evenly distributed pieces with same charge. And then superposition is used to find total charge of tape. Each U-tape has the same amount of charge evenly distributed along the length of the tape. And then the initial conditions were 2 pieces of neutral tape equal in length and a third laid out flat. Some of the calculations that were made are given right here to find the old values. And this is also from pulling values from lab 1 because I do use it later in this presentation. So these are just measured values that I then put into the computational model to get the most similar values. And then here's the actual computational model, where these are the physical constants. This is the value K, which is a constant used to calculate electric force. These actually were not used. I'm not sure why they're still in there. This is the force of gravity. This was the mass of one piece of tape, the charge on one piece of tape, and the width, length, and distance of those. And then you can see here, we find the charge of the charged particle, and then we find our R value, which is the observation location minus charged particle position, because it always goes from observed to source, subtract observed minus source. And then we calculate the magnitude of R right here and use that to find R hat, which is just the direction of R. And then we use all of this in the previous equation that was given right here to find the actual value of E, the electric field. And then in these following lines, we find the line charge at the top and bottom tape, and this is what makes the value more accurate. And so that is what we use here. And then following that, we have more calculation of the electric field at different segments. These DQs are the different chunks of the tape, and then they are all summed together to find these values right here, these arrows. And you can see that the value of the actual electric field is not greater than gravity. So according to my numbers, the tape would not have floated. But if you increased it, which I do later on, you can see that it would need that value of gravity to float above the other tape. And these are the 2 tapes right here. And then if we go into error, this is not error, but there's not really error in this. This is just a slide I forgot to delete, sorry. This is from the collection of the actual data from lab 1 that was used in here, because there's not really error in a computational model, I would hope. And then what if get a model, each of the tapes as a single point charge, and then compared to the estimated value of the line charge, we get these 2 values, which are drastically different, because the line charge is more accurate because it's closer. Also, this could have just been human error in my miscalculation of the actual point charge when I was doing lab 1. And then the estimates are different because the level of precision is much higher in lab 2, the step size in lab 2 is smaller compared to lab 1, so the model is more accurate. And you're getting a true value across the entire tape instead of treating the tape as a point charge, which would assume that all the charge is at a point on the tape, which is not correct. But thank you for listening. That is the end.